Good morning, everyone. We shall now take our topic about the principal roots and irrational numbers. Objectives. In this lesson, you will learn to describe principal root and tell whether they are rational or irrational. Number 2, determine whether what two integers the square root of a number is. Number 3, estimate the square root of a whole number. And 4, plot irrational numbers on the number line. Extension information. Exponent can be used to show that the number has been multiplied by itself one or more times. You can write 3 times 3 as a power of such as 3 to the power of 2 or 3 squared. Likewise, you can write 2 times 2 times 2 as 3 to the power of 3. And 5 times 5 times 5 times 5 as 5 to the power of 4. The power has two parts, the base and an exponent. So in the power of 2 or 3 to the power of 2, the base is 3 and exponent is 2. Perfect square is the square of a whole number. The number 9 is a perfect square because 9 is equal to 3 times 3 to the power of 2. Or 3 to the power of 2 or 3 times 3. The number 7 is not a perfect square because there's no whole number that can be squared to get 7. You know that 25 is a square of 5. Because 5 squared is equal to 25. You could also say that the square root of 5 is 5. The square root of number is the length of side with an area equal to the number. By definition says, when 2 is used as an exponent, the base is squared. When 3 is used as an exponent, the base is cubed. So the square root of a given number is a number whose squared is the given number. In symbols, a to the power of 2 is equal to b, or a squared is equal to b. The number a is called the square root of b. Notice that negative 5 is also a square of 25 because negative 5 squared multiplying negative 5 times negative 5 2 times by itself, it is equivalent to positive 25. The symbol of square root is like this. Like this one. It is used to indicate positive square root and is known as a radical sign. So the combination of radical sign together with the number is called radical. And the number under radical sign is known as radicand. So in the real number system, the square root of a negative number does not exist. This is true because there is no real number a for which a squared is negative. Therefore, the expression like square root of negative 9 has no meaning in a set of real numbers. So when n is an integer, the number n is called a perfect square. So here are 30 perfect square roots. They are called perfect squares because they can be arranged into squares. So, for example, the square root of 1 is 1. Square root of 2 is 2. Square root of 3 is 3. Square root of 4. So you can take a relationship, a ratio between a square root value that corresponds to a number. Or shall we say a perfect squared number corresponds to a number, a whole number. The square root of a perfect squared number corresponds to a whole number. So that should be observed accordingly. We will continue to the next. We have also the first 30 perfect square root, or perfect cube root rather. When you say cube root of a number, so it is a kind of a base number to be multiplied 3 times by itself. Then you will get a cube root. Like for example, the cube root of 1 is equal to 1. So next to that, what should be the number that will be multiplied 3 times by itself? So next to 1 is 2. Because 1 times 1 times 1 is 1. If you multiply 2 3 times by itself, so 2 times 2, 4 times 2, 8. Therefore, you can easily identify its cube root of a number 8. Cube root of number 8 is 2. So with 27, the cube root of 27 is 3, meaning we can multiply 3 times by itself. So that should be observed accordingly. The example, reading powers. Example number 1. So if you have 4 to the power of 2, that means to say 4 times 4. Or we can verbally describe it as 4 to the power of 2 or 4 squared. For the next example, 7 cubed, meaning you are multiplying 7 3 times by itself. And this can also be verbally described as 7 to the third power or 7 cubed. The third example, we have 8 to the power of 4, meaning you are multiplying 8 4 times by itself. So it can also be called as 8 to the 4th power or 8 raised to the power of 4. So in the next example, fill in the blank or fill in the box to make each statement true. Now what should be the number in the box, which is the power of 2, that will be equal into 225. So that number would be 15. Next, letter B, square root of 729. So think of the number that you are going to multiply 2 times by itself. So it can be equal to 29. So that is a number 27. So we can translate into exponential form 27 to the power of 2 and also raised to the power of 1/2, because a square root corresponds to exponential value of 1 half. So that 27 squared to the power of 1 half. So multiply 2 times 1 half. The result will be 27 to the power of 1. And 27 to the power of 1 is equivalent to 27 only. Okay, we will continue to the example, to the next example. Find the principal square root. So if you have a square root of 121, so what should be the number multiplied 2 times by itself that is equivalent to 121? That is 11. So 11 to the power of 2. The square root of 11 to the power of 2 is just the same as 11 to the power of 2 to the power of 1 half. Again, as what I've told you earlier, that 1 half corresponds to a symbol of a square root. So that 11 to the power of 1, multiply 2 times 1 half is equal to 1. So result will be 11 only. Okay, for example number 2, so the same process. We need to find a number that would serve as a perfect square. So what should be the number multiplied 2 times by itself to get a perfect squared number 49? And that is 7 times 7. So that the square root of 7 squared corresponds to 7 over 11. Again, so in letter B, we are required to find the square root of 49 over 121. So, since 49 is a perfect square, the number that should be multiplied 2 times by itself is 7. So that is 7 to the power of 2. And also 121 is also perfect square value, so it is 11 to be multiplied 2 times by itself is equal to 11. So, next step would be equal to 7 over 11 quantity squared. By the way, it corresponds to an equal value in exponential form. Just the same as the quantity of 7 over 11 to the power of 2 to the power of 1 would be equal into 7 to the power of 7 over 11 to the power of 1 only. So that your final answer is equal to 7 over 11. For letter C, to find the cube root of 343. So we must have to find a number that to be multiplied 3 times by itself, which is equal to 43. So the answer would be 7. 7 times 7 is equal to 27. Multiply it again by 7. So the final answer would be 343. So that the cube root of 7 cube is equivalent to exponential value of 7 to the power of 3 to the power of 1/3. So that would be 7 over 7 to the power of 1. Multiplying 1/3 times 3 is equal to 1. So that the final answer for the cube root of 343 is 7. So doing the same thing, finding the square root of 0 is 0. We shall continue to next. Okay, in number 4, you are required to find the two consecutive integers where the given lie, or find the two consecutive integers that makes this number given in between. So for the square root of 24, letter A, square root of 24 is not a perfect square number. So we must have to find a perfect square number where this square root of 24 is in between. So you can start with the nearest number you think that would be lesser than square root of 24. So we have square root of 16. Because square root of 16 is equal to square root of 4 squared, and 4 to the power of 2 to the power of 1/2 is equal to 4 to the power of 1, which is equal to 4. Definitely, that would be the least integer that should recognize that this particular radical number is between. So what is next to 4 is to multiply 5 times 5, and that is 25. So square root of 24 is surely in between the square root of 16 and the square root of 25. For a greater number, square root of 300. So what should be the number where the least value than 300? It should be to multiply 17 times 17, and that is equivalent to 89. And greater than that, we multiply 18 times 18, so it should be 324, which is partly more than 300. So that the final answer would be 17 less than square root of 24 less than 18. So the two consecutive numbers are 17 and 18. Letter C, square root of 110. So, obviously, 110 is between a perfect square numbers 100. So, square root of 100 is 10. And 11 times 11 is also equivalent to 121. So, 121 is the next perfect squared value, which has a base number of 11. So, most probably, 100 square root of 110 is between 10 and 11. For square root of negative 56, so we must have to find a perfect square number less than 56, and that is 49. So our lower boundary would be negative square root of 49, which is equivalent to negative 7. And the next perfect squared value is 64. So the square root of 64 is 8. So negative 8. Final answer or statement would be negative 7 is less than negative square root of 56 less than square root negative 8 rather. In example number 5, you are required to identify the following as rational number or rational. So again, the condition between or what makes rational different. Rational, these are the numbers which are whole numbers, counting numbers, integers, and of course including 0. And these are numbers who are repeating non-terminating value on numbers who are terminating value. And irrational are the numbers who are non-terminating, non-repeating numbers. So just verify the given, like in letter A, square root of 123 is an irrational number. For letter B, square root of 289 is a rational number. It is a perfect square number. The cube root of 216 is a rational number. Because it is a perfect cube number. And letter D, which is square root of 10 over 25, is an irrational number. So much for that. So much for our discussion. You try to answer the try-it activities and observe its instruction accordingly, follow the instruction accordingly, and so with the assignment provided here. Now, let's proceed to the idea of approximating the square root. So, the divide and average method can be used to approximate square roots. This method works as follows. If the square root of A is equal to B, then A is equal to B times B. Dividing both sides by B of the equation so that it would implicate to A over B is equal to B. This means that when A is divided by its square root B, the quotient is B. If we used to estimate for B that is less than B for the divisor, the quotient is greater than B. The average of the divisor and the quotient B can be used as a new estimate of B. But with that information, I would rather, here are steps also provided to us. The steps in approximating square roots A, you have to find two consecutive integers. B, you have to divide the number by estimated number. C, get the average of the divisor and quotient. And D, use the average as the next estimate. But I would prepare to follow this process. It would be more practical because these steps would let us determine exactly the approximate value of the given radical value to the nearest place that we are required. Like for example in number 6, approximate the square root of 40 in tens place. Just do in a division of numbers process, but there are some restrictions that you have to be observed accordingly. It's a matter of pattern that should be observed so that you are able to target the nearest tens place of the square root of 40 without using calculator. Now, 40 to be divided by the way, what should be the divisor, estimated divisor here? You have to think of a number that is a perfect square, and finding its square root, it should be nearest to the given radical value. And I think that would be 36. Because the square root of 36 is equivalent to 6. So partly, that perfect square value is very near to 40. But our target is to find its approximate 10th place value. So, the division process is a kind of division process. So, we will divide 40 by 6. Of course, that is equivalent to 6. 6 times 6, by the way, is equivalent to 36. And the difference is equivalent to 4. Now, on the other side, you have to think also the next step that we're going to do is to double. Okay, double the quotient that we have. And the double of the quotient, which is 6, multiplied by 2 is 12. And that 12 is a product, or as the double value of 6, should be our reference also of determining the quotient to a number. We all know that difference is 4. If we add 0 here, to divide it by 6, that would be 6 again. And we are not on the way of finding its approximate value. So the best way is to find a number that should be added to the digit of 12, make it 100 value. And that number should be multiplied also in order to serve as the quotient. So, meaning to say, instead of 40, we will add 0 to make it 400. We will bring down 0 to make it 400. And what should be a number to be added or to be put as the digit number of 12, that when we divide it by 400 to be equal into will be less than 400. So that number would be 3. So that 3 to be multiplied by 3, or 123 rather, multiplied by 3, that is equivalent to 369, which is pretty much nearest to 400. So that should be the value. So 3 will be put here. Where would we get the value of 3 here? Would be based on the number to be added as the third place of a number to make it a 100, and then that is to multiply also the same number. So 123 multiplied by the same number is equivalent to 369. So the result would be 400 minus 389. The difference is 31. I think we will stop on that because the requirement is only 10th place. So definitely, if you have a calculator to find the square root of 40, the 10th place would be 6.3. I hope you are able to understand my discussion here, and it should be follow up on the same. On another example, approximate the square root of 75 in hundredths place. So in this case, what should be the nearest perfect squared number to 75? So it is 8 times 8. That is 64. Because if we use 8 to 1, 9 times 9 is more than 75. So the less value to that perfect squared number, square root of a perfect squared number is the square root of 64. And that is 8. So we put 8 here as a reference so that we multiply 8 by 8, 9 degrees, negative 210 degrees Celsius, positive 181 degrees Celsius, and 113 degrees Celsius respectively. So you are required to find, in letter A, the difference between the melting point of lithium and the melting point of nitrogen. So the melting point of lithium is equivalent to 181 degrees. That is to be subtracted by negative 210 degrees Celsius. So it turned out the statement now becomes 181 degrees Celsius minus or plus 210 degrees Celsius. Again, there's a correction here. By distributing negative sign to the minus side, it becomes positive 210 degrees Celsius, which will be redirected, directly added by 181. So instead of 19 degrees, will you please correct it? The sum of 210 plus 181, so we have 391 degrees Celsius is the answer. For letter B, we are required to find the difference between the melting point of mercury and the melting point of nitrogen. So for mercury, we have negative 29 degrees Celsius to be subtracted by The melting point of the nitrogen is equal to negative 210 degrees Celsius. So that finalizing our statement, we have negative 39 degrees Celsius plus 210 degrees Celsius. Finding the difference between 210 by 39, the final answer is positive 171 degrees Celsius. Letter C. Find the difference between melting point of lithium and melting point of mercury. So 181 degrees Celsius to be subtracted by negative 39 degrees Celsius. So negative times a minus sign, so it becomes a positive 39 degrees Celsius to be added by 181 degrees Celsius. Final answer is 220 degrees Celsius. Okay, perform the triad activity. I think that will be all. This is your teacher, Mr. Cedric A. Borres. Thank you. To double 8 times 2, we have an equal value of 16. That 16 will be our reference also in finding the number that should be served, that will serve as a quotient, and also when we multiply it back to, it is less than 1,100. So where did we get 1,100? So the difference between 75 and 64 is 11. So if we put 0 here, it would not, it is less than if we add something to 16. Add additional number to 16. So we will add 0 to make it 1,000 numbers. And what should be, so that to find a number to be added by 16 and to be multiplied by the same number, it should be partly less than nearer less than 1,100. And by trial and error, you can do this. So as we multiply, or we add 16, if we put 6, for example, here, so that 166, we multiply it by 6 is 996. So I think it would satisfy the requirement that it is nearly less than 1,100. So that its difference is equal to 104. And 104, if we will add 0, remember, we are required to double the number we have. So 86 we multiplied by 2 is 172. So we are dealing with 1,000 numbers. Now, we are talking about 1,040. When we add number to 172, that will be more than 1,700 something. So, to anticipate that, instead of adding only 1 0, we'll add 2 zeros. And it will make it to 10,400. Now, what should be number to be placed in a digit of the double number 172? That we multiply, it will be less than, partly less than 10,400. And again, it should be a number 6 because we multiply 1,726 by 6, that is equivalent to 10,356. So it's less than, the product is less than 10,400, less than or equal to. So we were able to find the 100th place of the square root of 75 equal to 8.66. Now, in order to master the process here of approximating the radical number into a number place, so you have to practice it always. So this is meant. You have to answer approximate of 87 in 10th place. Number 2, you approximate the square root of 28 in 100th place. And for the assignment also, the square root of the 10th place of the square root of 11, 112. And number 2, the 100th place of the negative square root of 91. Okay, I think that would be all for this discussion. And this is your teacher, Mr. Cedric Borres. Thank you.